All right, 6.6, modeling with trig functions. So in this case, we did examples in the textbook. So we did examples from page 361, number 7. And here are the solutions to this, okay? Knowing the fact that you just have to deal with being able to read the function. So it talks about some minimum 500 hertz, maximum of 1,000 hertz, and if you were to graph it, you would have a function that starts at a maximum, goes to the minimum, starts at the maximum. In 15 seconds, you hear 6 times where the siren hit a maximum. And then there would be a corresponding minimum to get up to the maximum. And what you have here is the siren going up and down in terms of sound. Now, if you were to trace one of these functions, this is a trace of it. This resembles the cosine graph. The amplitude is going to be, you can figure out the amplitude and the equation of the axis based on the min and the max values. And you could determine the period based on how many cycles we have going on here to figure out what the period is. Once we know the period, we can determine the k value, because we need to find the equation of this function. So, 2 pi over k is equal to the period. You also have possibly a horizontal translation, or phase shift, which is the d value. So we need to find the equation of this function. First, we find the amplitude, which is a max minus the min divided by 2, which will turn out to be, in our case, 500 divided by 2, which is 250. The period is going to be, now this one's very important. How do you determine the period of this? Well, there are 5 different cycles here. 1, 2, 3, 4, 5. There are 5 cycles that happen in 15 seconds. We want to know how long it will take for 1 cycle. So, I'm going to take 5 divided by 5 to give us 1, because we want 1 cycle. How long that will take? Well, that'll be 15 divided by 5, which is 3 seconds. So it will take us 3 seconds to get 1 cycle completed. So basically you hear the siren from a loud to soft to loud again. So 3 is equal to 2 pi over k. Solve for that value. You will get 2 pi over 3 is equal to k. 3k is equal to 2 pi. 2 pi over 3 is equal to k. And then you'll also get the equation of the axis. And there is no phase shift because when we originally traced it out here, this trace, that first trace, it started at the maximum, which for a cosine graph, it will start at the maximum. So our equation of this function will be f at x equals 250, which is your amplitude. So you have your amplitude at 250. Cosine k value, which is 2 pi over 3, times x, plus the equation of the axis, which will be 750. So that is your equation of this particular function to deal with a siren. And there are other questions that deal with this, so I'm just going to show you another one over here in different values of degrees, and you have to find the equation again. So we look for the values, we plug it in, and once we plug it in, we could determine the equation of the function, and that's going to be the following. Again, this is question number 6, and we use the idea of how to find the amplitude. We use the period to find our k value, and once we do that, phase shift, we just look at the graph. Does it begin on the equation of the axis? Yes, it does, so that's our sine graph, so that is 0. There's no horizontal phase shift, and it is the normal sign and not the flip over version, so there's no negative. And finally, the equation of the axis is a max plus the min divided by 2. You can figure out all the information you need to find the equation of the graph. All right, now page 362, number 9, and talks about time and height and the fact that it goes up and down. and you have to find the value at when the graph reaches 50 meters. So this is you're on a Ferris wheel, and when it's above 50 meters, you actually see Niagara Falls. Goes down, goes back up. When you hit the 50 meters, oh, you see Niagara Falls for that moment in time, and then you don't see Niagara Falls again until you reach the top again. So imagine you're on the Ferris wheel and you're going around 3 times. It takes a total of 7.5 minutes to complete 3 rides. 2.5 minutes is to complete 1 ride. So we have the amplitude is the max minus the min divided by 2. It's the cosine graph. We want the negative cosine because it starts at the minimum. So negative is right there, cosine. And finally, we're going to find the k value, which is, it takes 2.5 minutes to complete. So 2 pi over 2.5, which is 4 pi over 5. So what does that mean? Again, one more time, you're going to switch these two. K is equal to 2 pi over 2.5, which is not allowed. You take that fraction and you find out the fraction is equivalent to 4/5. So it's 4/5 pi is going to be your k value. X, and then 4/5 x. And then you have to know the equation of the axis. Equation of the axis, you take this number, this value, 56.5, add 0.5, and then divide by 2, which is plus 28.5. Now, the question asks, at what times do you see the Niagara Falls? So, at 50 meters is the height, so it matches the height. So we set the equation and let f at x equal 50 and find the value for when the function reaches 50. So we isolate by moving the 28.5 over, divide by negative 28, and then note that cosine is negative in 2 quadrants, in the second quadrant and the third quadrant. So we do the cos inverse, and you get this value in degrees. Cos inverse will give you that value in degrees, and the other value in degrees. So we get those 2 answers. Don't forget to times it by pi 8 over, pi over 180. The reason why is you want it in radian form. Radian form will give us the values of, if we look over here, 140.1619 times pi over 180 gives you this value. And 219.8381 times it by pi over 180 will give you this value. Now, this is in minutes. You may ask to find out in seconds. So it starts at the 58.4 seconds, and then it stops at the 91.6 seconds. So we're talking about a 30-second view of Niagara Falls. All right, so what intervals will that be? Well, we have the first one, which is 0.97 minutes, and it will go to 1.53 minutes. These other values are every time it repeats. Remember that every 2.5 minutes, the function repeats itself. So if I had 2.5 here, I get this value. 2.5 again, I get this value. The same goes for when it ends. It ends at 1.53. Add 2.5, you get 4.03. Add again 2.5, and you get 6.53. And these are all the possible times in which you could see Niagara Falls during your 7.5 minute ride. All right. And that's the end of the video, folks. Hopefully these are some problems that you can go over in your textbook and review them. Take care. Have a good night.